So welcome everybody, good afternoon. Welcome to the second webinar of the YCN. Before to start, I would like to thank to the speakers of this afternoon, Carlos Velazquez and Francisco Veiga, the nice reply when we invited to be part of this webinar. And also I would like to thanks to all the YCN members and the participants of the webinar for the welcome to this project of the YCN Webinar series. So before to start with the speakers, I would like to explain who we are and what we are doing. The YCN was born in the framework of the European Ceramic Society, and our activities or projects are sponsored by the Journal of the European Ceramic by JECTRAS. JECTRAS is an agreement between the Journal of the European Ceramic Society and Elsevier, the tutorial, in which part of the benefits of the publication of this journal are returned to the European Ceramic Society, and they invest in young researchers. Well, the committee of the YCN is composed by 5 young researchers. We are coordinated by Veronique Huard, the Secretariat of ISER, and Andrat Koyan is head of the Young Ceramics and Training Working Group of ISER. This current committee is replacing to the former one to renew and get new ideas to the YCN. Well, the YCN is a platform that tries to provide to young researchers a place in which they can build their own network. We organize professional events to facilitate you make contacts, for links, exchange ideas. Also, we try to provide you information about funding and job opportunities. Our objective is to promote the research and the innovation in the field of ceramics. If you are interested, you can visit our website. In this website, you can find, for example, our map with some of the institutions of some of our members around the world. You can find the links to join us, and also a nice point is a place in which you can subscribe to our newsletter. Why these newsletters are important for you? Well, because apart to give advertising to our events, we dedicate 2 points to all of you. One is research in a spot, another one is industry in a spot. There the members can talk about their projects and their experience doing a PhD, for example, in the industry. It's important to say that this newsletter arrives to 11,000 people. Also, you can find us in social medias like LinkedIn. We are 650 members. In Facebook, we are 850 members. And recently, we arrived to Twitter and Instagram. Between our current projects is this, for example, this webinar. We started in November with Professor Richard Todd from University of Oxford. And now we are in the second webinar talking about sustainability and the approach of the industry to arise to this challenge. Other of our current projects is our special issue in open ceramics. We want to invite you to visit the website and see all the topics in which you can participate in this special issue. It is directed to young people. And the submission up to 31st of December are free of article publishing charge. Also, we are offering a best paper award for the best paper accepted in our institution. Finally, we are organizing a third photo contest. This nice picture are the participants of the second one, and you can participate up to the end of the year. If you are interested in us, you can join. You can find the links in the chat, so feel free to join to the YCN. Now we're gonna start with the first speaker, but previously I want to remind you that the question will be done in the chat, and you have to be sure to mark everyone. At the end of the talks, we make a kind of round table with the question, and you can talk with the speaker. So, please, I give you the pass. You can share your presentation while I introduce you. Well, Carlos Velazquez, born in 1970 in Barcelona. After getting his degree in economics and business in the University of Barcelona, he began to work in the international audit group PricewaterhouseCoopers. After 2 years as auditor in this company, he joined to the team in the international audit department of ROCA Group. Carlos has worked in ROCA during more than 25 years, and during this time, he held different positions. For example, as international auditor in the headquarters of Barcelona, controller of ROCA Morocco, administrative director in ROCA Tornerías, Portugal, CFO of subsidiary of ROCA Group in USA, and after USA, he came back to Barcelona and lead the corporate controlling department until he is transferred to Bulgaria as managing director. After Bulgaria, he come back to Barcelona and lead the creation and further development of the corporate marketing department of ROCA Group. Finally, in 2019, he gets the position of director in sustainability of ROCA Group. In addition to all these responsibilities, Carlos is member of the board of trusts of Wienerberger Water Foundation, trust of University School of Design and Engineering of Barcelona, president of the European Association for Taps and Valves Industry, vice-president of the Spanish National Association of Taps and Valves Manufacturers, chairman of the Marketing Working Group of the European Sanitary Ware Producers Federation, and chairman of the European Bathroom Forum. So with this nice curriculum, Carlos, I think you are a very nice speaker for this webinar.
Thank you very much, Maria. When I have the opportunity, I will share my my screen, because now I don't see the now I'm the presenter. Well, before presenting the session of today, thank you very much, Maria. Thank you very much, all the team of the YCN. I'm not young, I'm not a ceramist, but I admire what you are doing, especially in the industry that I work. Let me go to the presentation, and then I will be able to explain you the input in regards to circular economy from the industry. This is the real world. This is the day by day that we find big groups like ROCA when we talk about circularity, and especially in raw materials. First of all, yeah, I have been around so many years around the world, because ROCA is a very big group. We have 80 production plants in 20 different countries. We are 24,000 employees, 100 years of history, more than 100 years of history actually, and we are present almost everywhere. We are a big company. Even if we are a family-owned company, our income is 2 billion euros and growing. So yeah, this gives us a dimension, this gives us health, and our mission, it includes sustainability. Our mission, it is and has been for the last 13 years already, to leave the next generation of stakeholders, employees, customers, suppliers, shareholders, and the community at large, a bigger and a stronger company with sustainable profitability. So we are already thinking in the future generations. We want to leave a good, strong company to the future generations of stakeholders. How are we going to do that? By providing bathroom solutions everywhere in the world. This is our business. Our aim, to leave a company to the next generations. How? By producing bathroom solutions. We have done this for over 100 years, starting with cast iron radiators, cast iron bathtubs, then vitrochina, then faucets, then ceramic tile. And for 103 years, it has been difficult, but we have arrived here. Where we have arrived to the world that we live in today, a very complicated world. Our industry is facing big challenges. What we see is a fierce global competition. We see disruptive impacts of new technologies mixing with the old technologies. We see how the regulations are increasing, especially in terms of sustainability, as you all know. And how do we react, or how do we approach these challenges? Well, doing what we have been doing forever, focusing on sustainable growth, identifying what we do best, and then trying to replicate this to all the companies in the group. This has taken us to where we are today. And where we are today, it is a situation that it is new for all of us. With the creation of the sustainability direction in February this year, so it is not even 1 year, we decided that sustainability, it was not our pillar, one of the strategic pillars anymore. No, we took out sustainability from the pillars, and we put it above them as a frame. Sustainability is our frame. Is how do we create value? It is the umbrella. We create value beyond operational result. When we grow in a sustainable way. The same when we are excellent, when we innovate, when we walk the path of digital transformation, when we deal with people, we do it in a sustainable way for another 100 years. Another 100 years positively impacting the economy, society, and the environment. By the way, because of our industry, we impact directly with 5 SDGs, the Sustainable Development Goals of the United Nations. We directly impact good health and well-being, clean water and sanitation, decent work and economic growth, industry, innovation and infrastructure, and, of course, responsible consumption and production. We will be talking today about that, about the SDG 12. That doesn't mean that we don't impact the other SDGs, but in an indirect way. Of course, we impact number 14, life on water, life below water, because if we don't use plastics in our packaging, these plastics will not end in the sea, and probably some fish will live because of that. But we need to focus on the direct impacts today. And today, let me focus on number 12. Since we started the sustainability department in ROCA, the first thing that we did is create a team and to start analyzing the impacts that we have left in the last 100 years in terms of sustainability. We have started to put in place a system of KPIs. And there is someone in the team that it is controlling these KPIs. KPIs in terms of environment, social, and also economics. And based on that, we know where we are, and we can decide where to go. We have created 7 work streams to reach our sustainability roadmap. First one, it is decarbonization. Second one, it is sustainable materials. We will talk about this today. Third one is sustainable products. Number 4 is sustainable people, inside and outside the company. Number 5 is sustainable supply chain. We are not only responsible for what we do in our house, we are responsible for what the suppliers do that impact our processes and products, and what our products and solutions will live in the market when we sell them. It is an entire supply chain. Number 6 sustainable logistics. We need to be sustainable when we ship products, when we fill containers. And number 7 is sustainable communication. We need to communicate sustainability in a fair way, internally and externally. One of the projects that we have, it impacts the environment, and it is the ROCA program. The ROCA program, it is a project that involves all the productive sites of the group aimed to reduce CO2 emissions and to implement circularity. How do we do that? Let's talk about implementing circularity, and let's talk about ceramics. For ROCA, Vitro-China, ceramics, toilets, wash basins, floor tile, wall tile is the core of our business. And when we see a toilet like this, we may be confused because of the technology, because of the seat and cover, but remember that this is ceramics. This is clay and water. The bulk of this is clay and water, is ceramics, which is our field of expertise, like it is your field of expertise. Clay. I'm not going to discover the clay to all of you, because according to the Egyptians, the old Egyptians, the gods created humanity out of clay. I think that something similar happened in other religions, right? So it is a very well-known material, available, easily accessible, and naturally recyclable. The use of the clay pits can be restored easily, which leads us to an easy way to preserve the biodiversity. It is very local. Almost everywhere you find clay. Local production means local employees, local customized products. And you know that this product, after kiln, it can last almost forever. Because of the characteristics of the product, of this raw material, you know that if you are too much in the molds, the piece coming from the mold is not going to work. So naturally, this product requires the exact amount of raw material, not more, not less. Therefore, there is a natural consumption, and the consumption is minimized. We are close to zero waste in our production process. And as you know, we can reuse and recycle our products in our production. And not only. In fact, we reuse the material, we recycle the material, but also we recycle the water and the excess heat. Being young ceramists, you know that this is a tunnel kiln that heats up at 1200 degrees, generating a lot of heat. What do we do with this heat? Do we throw it away? No, no. Let's use it, let's clean it, let's filter it, and let's use it to heat up our warehouses or our dryers. This is circular economy, not only about materials, but it also about the gases, diesels, fuels, and waters. You know that a piece that it is not good before the kiln, you take it, throw it to the wells where we have the clay, and it's a natural recycle. You can use 100% of it. But that doesn't mean that if it is after the kiln, you cannot use it. Yes, you can use it. You can grind it, and you can reuse up to 10% every time. So even after the kiln, we can reuse. But here is the beautiful thing. There are some big companies, like the cement, the concrete factories, that they want this waste because for them, the grinded pieces that they are not good after the kiln are for them raw material. So we are ensuring 100% reuse and recyclability of the clay, of this fantastic material, which is the clay, the ceramics. Not only working on processes, also in products, in design. If you remember, probably in your grandparents, you may remember wish basins with very thick walls. Today, we have achieved fine ceramics. Ceramics that they are 3 millimeters walls. And we can produce these beautiful pieces that, of course, they use less raw material. And they are resistant as if it was in the past. This allows us to launch a set of products in the market that, like the houses, like the brick houses, like the ceramic tiles, like the clay pipes, expanded clay, or the sanitary ware products that we are selling, can live more than 50 years. And they live 50 years and not more because the fashions and the trends changes and people get tired. But if not, you could be using our products forever, or almost forever. I'm going too optimistic here. We have a good product. We have a sustainable approach towards this raw material, and we are achieving a lot of success, but it's not enough. And we have a lot of challenges ahead. We need to think in other ways to keep these materials longer in the economy, as long as possible. If we change our product every 50 years and it can stay for more, well, this would be better for the world, for the planet, for the people. And for the company, we will need to find other ways to meet the value. We need to design products for buildings that they are fit for the construction. Why, when we destroy a building, we need to destroy the ceramic tiles? If they can be recovered and send them to a museum, send them to a social house, we need to increase the reuse and the recyclability continuously. And if a cement company doesn't want our scrap, we need to find other ways. What we cannot do is to landfill this. Also, we have to give intrinsic value to this material before and after the kiln. This is not waste. This is a raw material that maybe it is not worth it for us, but it can be worth it for someone else. Let's find this someone else. Let's give this someone else the value that needs. We need to bring trust in these secondary materials. They are good materials, even if they are coming from wastes in one process. Maybe in another process are golden. And then what we need to do is to lobby for the regulation to give this trust to these secondary materials. And we should start thinking of them not as secondary materials for us, but primary materials for the others. And that's it. Thanks for your attention. I'm going to pass the word now to our second guest, and I will be waiting in the lobby for questions at the end of the session. Thank you very much. Back to you guys.
Thank you so much, Carlos, for your nice presentation. We're going to pass now to Francisco, and at the end, we made the questions. Okay. So while Francisco is sharing his presentation, I made a brief introduction. Francisco is a Marie Curie PhD fellow working in the ceramic industry Wienerberger, Belgium. His research is focused in the sustainable use of sulfidic mining waste in ceramics as part of the Project Sultan. During his master in geoscience, he gained experience as researcher within the biocritical metals project, where he co-authored a paper published in Scientific Reports. A part of his research, he has helped to found and develop a startup company, Geonatur, specialized in geological consulting jobs and promotion of geological and natural heritage in Portugal. He was also co-founder of WIDO, based in Utrecht, which aimed the boost of reusing and recycle of e-waste from individuals and companies through establishing the low carbon collection system. Other current positions include industry chair of the EAT Raw Materials Alumni Board, founder member and president of the General Assembly of the Energy and Climate Forum, vice-president of the Fiscal Council of the Association of Portuguese Students, Researchers and Graduates in Belgium, the Netherlands and Luxembourg. So, Francisco, you have the word to do your presentation. Francisco, I think you have to unmute. You see in your screen in the down part.
No, I think it's okay.
Can you hear me now? Okay, I will share it again if Vero pass me back the chance to share. Sorry, yeah, great. First of all, thank you so much, Maria, for this invitation and also to have this opportunity to share a bit more of my research with experts in the field. So I hope to also pass the message, and great work that Young Ceramists Network is doing on boosting the connection between academia and the industry, which is essential to also better prepare professionals for future challenge. So first of all, as mentioned, I'm part of Marie Curie ETN program around the remediation and reprocessing of sulfidic mining waste sites. This is a project, and I want to talk just a few words about the project background. It is composed by 8 beneficiaries and 7 partners, and we are dealing with 3 main research material providers, which gave us these mining waste materials that a team of 15 researchers divided into work package is trying to find new ways, a novel approach to not only map these secondary sources, these mining waste deposits, but also to apply novel and sustainable leaching process to recover these valuable elements that mining waste contains, such as bio-leaching and microwave leaching. Myself, I'm on the work package 3 on the mineral residue valorization on the ceramics field, along with 2 colleagues that are also working in organic polymers and green cements. Lastly, but not last, 2 ESRs are doing the whole environmental assessment and life cycle assessment of the whole project. So to talk about my research topic, I would not start without giving you what is the problem that I'm tackling. Not only the resource scarcity on the geological resources that is limited, but also this pressure over this primary raw material sector and the external market dependence in Europe from external markets and critical raw materials lists being published every 2 to 3 years by European Union, targeting what is the most needed raw materials, associated, of course, with the landfill problems that all these mining waste materials have associated, the costs for a company to do so, the regulations, the environmental and health hazards such as ice mine drainage and many others can affect the surroundings. And last but really important, and this is a message I want you to take home, is to stop calling waste waste and start calling it resource. Because indeed they are only considered waste until we really mean to put a waste label tag on it. Up to there is potential in this waste to turn into a resource. So there is this lack of resource information regarding the properties, and also the segmented markets, also to sell and make a marketplace, and also new business opportunities. So the topics and the goals are around this circular loop that is never closed loop, because you always have these residuals, and I call them residuals and not waste, because they are residuals until we also give them we repurpose them. So is this that I'm tackling is turning this mining waste material with all the associated environmental and health hazards that landfill this waste can contain, but also turning it into a resource and moreover to a certified product. In my case, ceramic roof tiles, blocks, pavers, and others. So this, it's the main goal of my research, but this figure can be applied to any material you can find. What I want to emphasize is that the name circular is really easy to explain. It's just a closed loop, but it's never closed. And our biggest challenge is to try to close that loop, even though we would, in an optimal scenario, we will never close completely this loop, but you will want to minimize this loss of values that every material can have. As Carlos mentioned, why we destroy a house? Why we destroy the tiles, why we landfill them, why? Because we also don't have the means and the platforms to also funnel it and channel it, or you have other bigger players that also play a role on that. So I do think this, along with legislation and also key stakeholders should play a role on this mapping of secondary sources. My materials that I've been working, as mentioned, are 4 materials, 2 tailings, one from Plombieres, which is in eastern Belgium, from an inactive mine, as well as an inactive mine in Germany, eastern Germany, Freiberg, and also 2 waste rock materials from Neves Corvo mine in the southern Portugal. Then initially on this first experiment, I integrate initial 5% of these 4 mining waste materials, all separately, in roof tiles, along with the company specific raw materials. And also in blocks. In blocks, you have a wider range. I wanted to emphasize here that the company Wienerberger, which is a big player in the production of ceramics, is already minimizing some of its ecological footprint, because one of several, actually, one of the roof tiles raw materials is an imported filler, which is already a byproduct. And on the blocks, you have way much more. You have all the fillers and also an imported waste source that comes by byproducts processes from other industries. Emphasize that the waste rock, as is a coarser material in this image, you can see was already shredded to be possible to integrate into the ceramic mixtures along with this company specific raw materials. And these 2 ones didn't need any further processing. The methodology, of course, you need to map out to characterize all the physical, mineralogical, and chemical, thermal, and even environmental compliance tests on these raw materials, and also even more on mine waste material, which are not common in this sector, and then produce the ceramic mixtures and the test pieces, and then do this quality assessment on the test pieces. And if you are satisfied, you go over to this also environmental compliance tests on the fired products, on the shaped product itself. If not, we always trying to remediate testing other mixtures, different products, or even different firing temperatures. As mentioned, I've been working up to now with roof tiles, blocks, and pavers, and I target also to integrate into ceramic pipes and facing bricks. A bit on the characterization of this mining waste material, even though it's sulfidic, so you indeed have some pyrite content in some of them, but the majority is composed by quartz and phyllosilicates such as muscovite or chlorite. And the pyrite is present indeed in the Freiberg and Neves Corvo waste rock materials and Freiberg tailing. And indeed, it goes along with the major elements composition with high silica, alumina, and also iron oxide content, as well as sulfur trioxide. For the sulfur, we tend to look more into the total carbon and sulfur composition here at the lower left, where you can see that indeed the three last mining waste materials, Freiberg and Neves Corvo, have higher contents in carbon and especially in sulfur content. We cannot really integrate the waste without doing legislation procedures. On this case, we in Belgium, where I'm based, and in Flanders region, they have the Vlarima. Vlarima, it's a test to use to assess the potential use of these waste sources in building or construction materials. If you have a non-shaped product, which is the case of mining waste, you always need to do a total organic compound analysis. With that, you have limit values. So if the product goes over these limits, cannot be declared a raw material and potential raw material to use in ceramics. But if it is within, you can go to other tests. The total element concentration, these are guidance values. So this means that if it overcomes, and you will see that here, indeed, some of the materials, as I mentioned, Freiberg and Neves Corvo, overcome the established limit. Nevertheless, you have a second test, second chance, let's say, to also do a column leaching test on this granular material. And if the material passes this test, it can be considered to use as a granular material for road constructions, field hawkered, field dams, etc. On this, you can see that indeed the Freiberg tailing and the Neves Corvo stored. The main difference between 1 and 3 is that the waste rock 1 is fresh material and the 3 is stored material in an open stockpile. And indeed, both of them go over, so they cannot be considered a granular, certified as granular material. Nevertheless, they always have a chance, because they didn't went over the organic compounds, to be integrated into a shape material and do a different leaching test, the diffusion leaching test, which is another test for the shaped materials. And if it passes, you can definitely integrate them into shaped products. So the preparation of the ceramic mixtures, as mentioned, I started with 5% in roof tiles and also 10% in blocks for the mixtures. With that, I look to the grain size distribution and especially to the sieve residue, the over 50 micron fraction, and also try to balance the mixtures. And of course, if you take clay, you should replace with a clay-like material. In this case, really Plombières tailing case material is the best fit when you are doing. That's why you see here that we took -4% of the local clay and only 1 of sand, while with the others we took 5% from the sand. With that, we do the normal procedures from the hand mixing to the mixing machine to the vacuum extrusion of these roof tile and block test pieces, caliper marking for drying and firing shrinkage, drying in an industrial chamber, and in the lab firing in an electric kiln. At different temperatures, we fire the roof tiles mixtures on average of 985 degrees Celsius and the block mixture at lower, 965 degrees Celsius. With that, we have the fire test pieces. On these fire test pieces, you can see how definitely the high content in carbon and sulfur influence the black core formation on the mentioned mining waste tailings with this high content. Of course, this carbon and sulfur are oxidized, and especially the sulfur oxides create this reducing atmosphere that during fire creates this black core formation. This black formation, especially in roof tiles, is quite a point to make reference, as the black core formation also reduce the durability in the frost-thaw cycles, so the frost and defrost cycles. So that's why in the reference, and you see that Plombières is really close to the reference visually and also chemically, as you will see now on the soluble sulfates and also efflorescence test on these two products. So you can definitely see a similar correlation on the soluble sulfates content in the roof tiles and also blocks for the reference and also the Plombières, whilst all the other more unclean material, let's say more dirty material, have higher numbers, which also show a bigger efflorescence, salt formation. So calcium sulfate is also formed and by capillarity reach this surface of the roof tile test pieces. There is a case that even though it has lower than the stored waste rock material from Neves Corvo has a lower percentage on soluble sulfates, here but still high, you don't really see it and is really comparable to the standard. So definitely here, the pore structure and the capillarity also plays a role for not giving the efflorescence marks. On the blocks, at the other hand, as you see also here on the black core formation, you see that even the reference, because it's also a different material, a different product, you apply inner wall, is an inner wall application, doesn't have the climate factor as the roof tiles. So the black core is also present on the reference. And then you see slightly all over this a more denoted black core formation in all the other materials, even the Plombières material. So this definitely different mixtures plays here a role, and each product behaves differently, also the firing and sintering processes. On the technical results, it was concluded that indeed the Plombières is the most similar to the reference. In some cases for the blocks, even increasing the elasticity strength, the modulus of elasticity, the E modulus, which means also that there is a more denoted black core from all of them, which also increase the strength. There is a straight link between these iron oxides that get trapped during the sintering process and the increase in strength. Moreover, more tests are also done on the technical, also the water absorption on progressive and also vacuum conditions, and also the modulus test by a non-destructive method. The conclusions is that indeed the Plombières tailing material is a fine-grained material, as low sulfur and heavy metal content is within the legislation, and this to note, as I mentioned at the beginning on the material section, is that they didn't need any further processing before integrating straight into the mixtures. This means for a company no extra costs and really good suitability to integrate. Of course, as mentioned, the technical, aesthetical, and chemical properties in general were very similar to the standard with the Plombières tailings mix, and definitely is out of all these assessed materials is the best fit to partially or totally replace some of the primary raw materials as clay and sand in the roof tile and block mixtures. All the other ones indeed present exceedings, even though Freiberg is fine tailing material, it can be straight away integrated into the ceramic mixtures. It has a lot of sulfidic content, which also gives bad results on several other properties. So there is a need of this mining waste to be cleaned, and it's exactly that my ESRs, my researcher colleagues at Sultan already provide me with. I not only increase the optimal material on my ceramic pieces, but I also start using the clean Freiberg tailing at the initial 5 and 10%, 5 in roof tiles, 10 in blocks. And I integrated a new ceramic product. I integrated the mining waste into a new ceramic product, with higher firing temperatures. And in this case, I also integrate all the unclean mining waste, because if it also fires higher, it means that more volatile, so perhaps less sulfate content at the end. On this second experience, I produced several ceramic mixtures, increasing the Plombières and also comparing the non-clean and the clean Freiberg tailing. And on the preliminary results, you can see that indeed Plombières, even if you increase to 20%, there is no black core formation. Means a good, already clean material, even though in the efflorescence test you can see some efflorescence stains coming up. And on the Freiberg material, as you see, the non-clean and the clean, there is a decrease on the black core zoning. But this also shows that here on the efflorescence, you also have some different results. So there is more efflorescence on the non-cleaned than on the clean one, which is expected to have less also sulfate content. This, as shown here, soluble sulfate content decrease indeed on the clean one. Nevertheless, is still high to integrate into the ceramic mixtures. This was also applied to the blocks and also pavers, where you can see that actually with 20% of Plombières in the blocks, you get rid of the black core. This is not a good sign, could be on the roof tiles, not the case as the blocks. As I mentioned, the black core also gives strength, and the strength is one of the main features of inner wall blocks, such as foundation blocks of any construction. So on this case, sometimes it's good to play with the mixtures. You get some results which could be suitable for other products, but not the one you are working with. On the pavers is really a different mixture, and you fire higher. So you see kind of a similarity also on the efflorescence marking, even though it's not here represented. This is the soluble sulfates of the content of the roof tiles, but indeed there is a slightly increase towards this more uncleaned material on the soluble sulfate content, which show also slightly more efflorescence marking. This cannot be done and closed with the leaching test, the environmental legislation test that you need to do when you produce a shape material. Here, as you might know, you might seem that there was an error by me, but it's indeed, we are doing column leaching tests, which are leaching tests for granular material, and we are doing for shape materials, and we should follow the diffusion test. What happens is that the future legislation will look more into the second life of materials to also help closing the raw materials loop and promote better use and more resource efficiency. So that's why it's really vital for you to also grind all this material as in a scenario as if you dispose in landfill or construction and demolition waste, which normally comes also some granular material. So you also have to see how much metalloids leach out for the environment, and if they are possible to reuse in other applications. This was a test that was done in V2, a research institute in Belgium, and it showed really positive results, especially on the Plombières and also Neves Corvo fresh waste rock, as already the mining waste material pass all these column leaching tests. My upcoming steps are, of course, this second experiment with this increase of Plombières tailing, the leaching and paver results. Always full characterize the cleaned mining waste materials that I currently have, and incorporate them in studied ceramic products and other products such as pipes or facing bricks. This is the current image of the cleaned residues from Freiberg, Neves Corvo fresh and stored waste rock. And finally, during this presentation, we took around 20 minutes. There was produced at Wienerberger production plants in Belgium, 11,280 pieces of roof tiles. And for blocks, because we consider only one Belgian production plant and only one production line, there was 406 pieces produced during this presentation. So my question is, can you imagine how many tons could be turned into a resource and applied to different products? Thank you so much for your attention.
Thank you so much, Francisco, for the nice talk. Well, just to remind to the participants, if they want to make a question, just write in the chat in everyone, okay? So we can start maybe, I don't know if the speaker want to do a comment after the talk before to start with the question. Okay, so maybe we start with the question. Thanks for the presentation. Have you ever tried recycling a material which has been affected by carbon oxide or soot or not?
Again, Maria, have I ever tested a product that has been affected by?
You can read also in the chat if it helps you. Have you ever tried recycling a material which has been affected by carbon oxide or not? I think.
No, indeed. I never ever tried this type of material. The mining waste material are also, as shown, some of them has a lot of total carbon, and this carbonaceous matter also contributes a lot to the black core formation. So that's why also a bit on the traditional ceramic production, they tend to also go a bit away on the organic content, carbon, and also sulfate content on their mixtures, of course. Thank you.
Okay. The next question, I have a question for Francisco. What is exactly an efflorescence test?
Okay, efflorescence formation. Okay, the calcium sulfate. So what happens, and I don't know if I can, yeah, I cannot share, but doesn't matter. I can tell you that I cannot share. No, doesn't matter. Okay. The calcium sulfate that is formed between the reaction of the calcium oxide and also the sulfate content on these mixtures is the reason why this efflorescence mark occurs. And of course, the capillary flow of these species also plays a role in showing these crystals, this calcium sulfate gypsum, if you want, on these species. That's why when you look at buildings, you sometimes see some marks on it, you know, because sometimes it's really hard to also control all this, because a lot plays, is the chemistry, is the physics of the material, so it's a lot. So of course you have to lower down these levels, of course, of carbon and sulfur, which can also contribute to this. But this definitely, in short, is the calcium oxide reaction with the sulfate content that creates this calcium sulfate, which by capillarity reach the surface, which is soluble, of course.
Thank you, Francisco. Next question, maybe it's more directed towards Mr. Velazquez. Do the ceramics you produce undergo any final treatment process before entering the market? And if yes, do they involve the application of any finishing coatings?
Yes. Let me tell you that, as you know, when we put the piece inside the kiln, it has gone through a process of mixing, molding, drying, glazing, drying, and kiln. And after the kiln, it is sorting and packaging. But now, imagine that, for instance, for our series, we have a series that it is called Armani ROCA, and it is done with Giorgio Armani, where we apply a decorative coating. This decorative coating, it is like a layer of film on top of the piece, and then it goes to a shuttle kiln, not a tunnel kiln. It's lower temperature, it is less time, and then it fixes this second coating. This is a decorative coating. We have another thing. Imagine that we want to buy a product from ours that it has antibacterial coating. Then how do we do that? By applying a coating, a protective coating, antibacterial, and this antibacterial, then it is applied in some cases, it's on cold, and some others, again, it has to go through the second kiln, what we call the shuttle kiln. So yes, the answer is yes, and we have different technologies and different processes and methodologies depending on if it is decorative or more health related. Now, you will be asking me now, are you thinking on applying a coating for COVID? The answer is yes. But, and we are working with a research center in Switzerland, but applying this COVID, anti-COVID coating into metals, it is easy. But embedding this into the ceramics, it is very difficult. And so far, we are not achieving results. So very openly and very honestly, yes, but in some cases it's easier and some others needs more research.
Thank you, Carlos. Next question, looking for small cities, what will be the role of any approach related to ceramic materials, and which research field of ceramic science and technologies to invest for contribute further in this approach?
Now, let's see.
What will be?
Ceramic material. I really believe that in the next in the smart cities, all the noble materials, they have a place. Noble materials are here because they have proved that they are resistant to trends and they are resistant to time. So metals, ceramics, for sure they will be there. They have proved that they are in our lives. We eat with ceramics. We live inside ceramics, and it's part of our culture. It's part of our lives. So they will have a role in the smart cities more and more, and not only as a first product, but as an auxiliary product, as Francisco was pointing out. And now, in terms of sustainability, it is a trend. Somebody is asking me for this question. Well, what it is, I don't know what's going to be. I don't know if it is a trend or not. What I know for sure is since the Industrial Revolution, there has been the great acceleration. That means that we are consuming all our resources much quicker than we can afford. In fact, some resources in 2020, we have been consuming them by July or by June. And we are in December, so we are taking back something that it is not used, not to be wasted. Now, it's not a trend. It's not a trend. It is a need. Otherwise, we will ruin the planet and we will ruin ourselves. I don't know which is the right road towards sustainability. Honestly, I tell you, when they told me about decarbonization by 2050, I don't know how I'm going to do it. Because the green hydrogen, the biomethane technology is still not affordable and feasible. So what? Do we do nothing? No. We need to start doing what we can, solar panels, heat recovery, and start analyzing and researching for these new technologies like hydrogen, like biomethane, or even thermal, solar thermal. But what happens? That these roads are uncertain. And I don't know where it will take us. But one thing is sure. I know where the road that we are all driving will take us, which is to destruction. So, yeah, it's not a trend, it's a need.
Okay, thank you. A question for Mr. Velazquez. Is sustainability a current trend now for the most of the companies, or just some of them are starting to think in this way? I think
no, exactly. This is what I answered, Maria. And again, it's not a trend; it is a need. For the most of you, if you go to the internet and you watch, you search for great acceleration, you just search for great acceleration, and you will understand what it is taking us. So it's not about companies, it's not about governments, it is about all of us to make actions, even in our current domestic day by day.
Okay. Thank you, Carlos.
You welcome.
Maria, I would like, if I can, if you don't have any more question, I would like to compliment Carlos and emphasize what Carlos' presentation also gave me, because I put here some notes. And it's definitely this rethinking and reshaping the sustainable goals of every company, that not only now, but now there is the need, as Carlos mentioned. Why? Because if we keep up, we need to lower down our consumption habits, first of all, and we have a responsibility. Each one of us at our home, we can do that. But because also you have some interest from companies, marketing, and you have enablers that allow you to go to a shop and just buy it without even knowing the footprint of a device as or a material as. And this is what is this transparency. It's the need also, and companies want, with sustainable development goals as ROCA and also Wienerberger, wants this transparency. Of course, they are privately held, so of course there are some secrecy in some extent, of course, to do business and not showing all the ceramic mixtures, all the materials, all the exact ratios and everything, of course, but telling, yeah, this is possible. With these secondary sources, it's possible to minimize this ecological footprint. So this is the first note about the rethinking and reshaping also the industry itself and boosting even more industrial symbiosis between companies. As Carlos said, I mean, a company could want to do something, why not collaborate in a way that can both minimize their footprint, their ecological footprint. Second thing, and I think is really a need, and is what Carlos is doing so good, is communicating clear sustainability. What is this? This big word, or just word that you keep hearing with circular economy, with the SDGs and all the COPs and everything, and the Paris Agreement. This is a need that all the industries were overdoing things. Consumption also comes from us, but also the industry plays a role because it's an enabler for us to do so. So there needs a balance. The Mother Earth needs this balance. And I think Corona also make a lot of people rethink also their purpose in life, because we will not last a geological period. We are not even, I mean, the plastic we produced was already considered one of the geological time frames. So this is impressive. In such short time, we already left a big footprint. And lastly, it's what I mentioned also, why destroy? Why to landfill? Why not to, because we also don't have yet perhaps so much funding into the technology needed, but the knowledge is getting there. And by connecting, as Young Ceramist Network is doing, connecting research with industry, we can apply this and progress towards a more sustainable future. Thank you.
Universities and companies, research institutes and companies and NGOs. I'm going to answer another question that I have for me. With SAGMI, Riedhammer, Offenbau, we are working because we have over 140 tunnel kilns in the company. So with our partners, we are dealing with the heat recovery, with the burners. Can we use hydrogen in our burners without changing the burners? Well, up to 30%. Okay, can we try more? This is what we are doing, researching, because what we cannot afford is to change all the technology and all the assets. We would die. So we need to do it step by step. Now, are we working with these tunnel kilns producers on the formula? No. No, we are working internally and with the providers of minerals. Why? We have engineers, ceramists, that they are working together with the providers of these raw materials to find this ratio of reintroduction, reuse, recycling into our process. When I started in ROCA, we were talking about a 5% reintroduction of a grinded scrap, grinded auxiliary product. And here I listen to Francisco. I'm not talking about waste or scrap. Only 5%. 25 years later, I'm talking about 8, 9, and up to 10% in some companies of ROCA. So yeah, we are analyzing this. We are improving every day. Small steps, big results.
Thank you. I am happy with your replies because I see we are getting one of the proposed with this webinar is make diffusion about the big challenge we are facing, the companies are facing to get this sustainability, this circular economy, and how we can collaborate, researcher and industry, and for get this challenge. It's a big challenge, but it's possible. But we have to start. So I am very happy about this discussion. We continue maybe with the question. Next question say, effluence test, recycle of partial distilled water immersion and drying overnight 50 degrees, the 5 pieces.
No, that was my reply to someone that asked how you do the efflorescence test. I think it's the last one I have.
Okay, thank you. So maybe other question for Mr. Velazquez, or also you are invited, Francisco, if you want to reply.
I think
one for Francisco.
I think I have one. Yes. Thank you, Carlos. Thank you for the nice presentation. Thank you, all of you, for listening to us on this digital fatigue time that we have in front of our laptops. The question is, did you do the bending strength test and thermal conductivity for on your test samples? The bending, compressive, or flexural strength are normally, the compressive is not done on roof tiles, rather the flexural, but we don't do that because our test pieces are also not proportionally comparable with the final product. So with that, we prefer to do a non-destructive method on these test pieces. And as you see, the roof tiles, we produce tiles, so they are more similar to a real shaped product, a real roof tile. But the blocks, they don't even have the perforation as the normal porotherm block of Wienerberger has. So indeed, these are tests on the fired mixture itself. Of course, it correlates a bit with the final product, but this compressive strength or flexural strength are not done, these destructive methods. And also the last one is if we do any thermal conductivity, I do thermal analysis on the unfired, on the raw materials and unfired mixes, but no, we don't do any thermal conductivity on these samples.
Okay, thank you, Francisco. Correct me if I am wrong, because maybe I lose some questions for some reason. I think the next one is for you, Carlos. Is there a way to increase the ratio of recycled products in your production, 10% at the moment, if I have understood, for example, by involving process manufacture like
SAGMI
in the loop?
Yes, this is what I said. So yes, we are working with SAGMI and the kiln producers in the heat recovery burners, efficiency of the kilns, and on the other hand, with our ceramists and the minerals, raw materials providers on the reusability of the raw material. Yeah, I think that we have covered all the questions so far.
Yes, so thank you. I don't know if you want to comment something else. I repeat one again, I am very happy about this discussion. And I want to thank to you again, Carlos and Francisco, your presentation. And you know that you have in the YCN a new network for collaborate, all the ideas, all the projects you want to put to run, and you need the YCN, we are here for you.
Now, everybody at the Young Ceramics Network, it has been a pleasure. You have made this session very easy. I know now about you. Now you know about me through Maria, through Vero. Please, if you need anything from me, from ROCA, channel your requests, questions, comments towards them, and they will let me know. And before saying goodbye, Francisco, it has been a pleasure to know a young scientific like you and what are you doing, and in the quality of detail and the high level that you are doing it. Congratulations to all of you, and it's been a real pleasure.
Okay, thank you. Just I still do a couple of minutes more before to finish this webinar.
I would also like to thank, and also this synergy between all of us that are from the same area but different areas. So I do think it's really vital for you to boost this and create this space of opinion and also sharing knowledge. Huh? After all, sharing is caring. Huh?
Yep.
Okay, so thank you again to both of you. You are welcome to the ICN for everything. And just to finish, let you know that we will come back the next year in January with more projects with a new webinar. The registrations are now open. Please keep connected to our social media to know about our projects for you, for help to you to make a network. And finally, we want to wish you a happy new year. All the best for 2021 to all of you. Keep safe, care yourself, care your family and relatives, and see you the next year. Thank you so much.
Thank you very much. Bye-bye, everybody. Hasta la
Thank you
vista.
all.